I am just delighted to have, and I'll stand over the shoulder so you can hear the mic. I am just delighted to have Dr. Gerald Friedland, who is a friend of us from ICSI. ICSI is a research, independent research institute that happens to be downtown Berkeley, and it's amazing. They've got some incredible theoretical computer scientists. Folks from all over the country are here as visitors and work with ICSI, and Gerald is working as a researcher there. He's an expert in privacy and the internet, and it's what a perfect connection that we've made between what we need for our class is a discussion about social implications of computing and his research. So I'm glad that he found me, and I'm glad that we can make this connection. And this is the first time he's coming to give a guest lecture on CS10, so let's give Gerald a hand. CS10, come on.
So yeah, thank you for the introduction. I'm really happy to give that lecture. It's really coming from my heart a little bit. So this is a lecture I basically created out of a research talk that I'm giving, I have given it several research places. So it's a little researchy. Bear with me if there's a couple of details you might not understand. I hope you still get the right stuff on. The other thing I wanted to say after that awesome introduction, I don't have to do anything anymore, is if you have any question, or you want to see some more, this is my email address. Feel free to send me email anytime, like after the lecture, during the lecture, probably not, but after the lecture, and whenever. Don't hesitate. Maybe in a couple of years when you start doing work like this, just send me email. Don't worry. I'll respond. Okay, so let's go ahead. There's several ways I could introduce the topic and tell you what I'm going to talk about today. But sometimes it's really funny when I watch TV and somebody does it even better than I could ever do it.
One of the ways I'm keeping the public's eye on me right now is social media. I am all over Facebook, MySpace, Foursquare, Reddit, LinkedIn, Google Buzz, LiveJournal, Blippy, Twitter, Tumblr, Flickr, Muffler, Flumpler, and let's say Gargler. You see, social media is the only way to reach young people these days without giving your abs a nickname. And evidently, nobody liked the laundry sack. But kids, all this online openness comes with a price.
I know people who've been let go of their job because they shared a little bit too much about what they were doing online.
If we're hiring an intern or a new employee, the first thing you do nowadays is go online and look at their Facebook page.
The pictures of you shooting back tequila shooters, pole dancing, not information that your employer wants to see.
Especially if you're working for your dad. Even Barack Obama knows the dangers.
I want everybody here to be careful about what you post on Facebook.
And the president has been very careful. I have checked Facebook, and I could not find a single photo of him praying in a mosque. So, I photoshopped one. It's on Twitter. It's on the Twitter, so internet, do your thing. The point is, if you're not careful, your online past could destroy your offline future. But there's a solution. And it's tonight's word. Control self-delete. Now, some folks will say the easiest way to protect your privacy is to stay off social media. But even if you do, other people can post pictures of you online. Luckily, Google CEO Eric Schmidt has a way we can protect ourselves.
If you have something that you don't want anyone to know, maybe you shouldn't be doing it in the first place.
Are you listening, young people? Just don't ever make a mistake. How hard is that? The point is, the internet is one giant resume. And under special skills, yours might list getting high, keg stands, flashing your boobs, and multitasking. That's why Eric Schmidt further suggests that every young person one day will be entitled automatically to change his or her name on reaching adulthood. Exactly. From now on, changing your name will be a rite of passage, like getting a driver's license at 16, drinking at 21, and completing rehab so you can get your license back at 23. But changing your identity may not be enough because now Google offers a facial recognition feature which can identify you in unlabeled online photos. So, you really need to surgically alter your appearance. It's easy. Just ask Bruce Jenner. No, Jimmy, I said Bruce Jenner, not his mother. Okay. But even this may not be enough. You see, Gmail keeps track of everyone you have ever emailed. So, you'll want to get rid of your old friends and family. And since Google also tracks all your searches in web history, you should change everything you have ever searched for on the internet. Then, once all that's done and you're a disfigured, nameless loner, you'll be the ideal job candidate. Of course, there is one other answer. Google and Facebook could stop invasively data mining and selling our private lives to the highest bidder. But that would be asking them to change who they are. And that's not fair. And that's the word. We'll be right back.
So I'm working in this, and most part of this lecture is basically my work is to make the stuff objective, right? So I can't go out and do a comedy about it. I actually want to know scientifically what the problem is. And I'm going to forward a little bit to what our observations were when we do this kind of research. So our observations were many internet sites and mobile apps encourage sharing of data too easily, and the users don't question that and just do it. Second, it's not only about the users, right? So it's often easy for computer scientists to say, oh, the damn users. It's not really. It's also the engineers often underestimate and are unaware of the hidden search and retrieval possibilities of shared data. What I mean with search and retrieval possibilities is not only can you go online and check out the pictures, but you can also write programs that basically correlate data across sites and then basically do data mining on this data. And often engineers don't think that far. And especially because what engineers mostly think about is local privacy protection. So you set up a website that does something with people. So you really think about, okay, the data they give me, I can't give that away. What is the part I can make public? What is the part I don't? What is the part I sell? That's also part of it. But then in reality, they don't think about the fact that, of course, like if you put stuff on Facebook and on Twitter, other stuff, and on Craigslist, other stuff, that it's all stuff that's in one internet, right? And so Craigslist doesn't really care about what you care on Facebook, or Facebook neither. But in the end, somebody should care because you can correlate. And that's exactly what basically this talk is about. And there's also a social cause for that. One social cause is people want to post on the internet, A. It's sort of like, seems to be a real important thing. And B, they also like a highly personalized web experience. So the reason why sort of Google keeps all that data is they want to do targeted advertising so that you get only the ads that you're interested in. It's actually a good thing, right? So you don't get ads that you ignore anyways. You get ads that you might actually be interested in and buy something that might improve your life. So it's something people want. And then, of course, the problem is because everybody posts into the internet, then we need to find the stuff after we posted it, right? And since it's getting more and more and more, and I'm going to talk about how much more it becomes every day, we have to improve the techniques to search and retrieve the data, to basically find the data for you, to find what you're looking for. And then governments like that too, because they used to install all these security cameras everywhere, and then people were protesting. Nowadays we have cases solved by actually going on YouTube, seeing all the sort of vacation shots of people around the area of crime at the right time, and that is sort of like living surveillance cameras, and each of them is basically crowdsourcing the surveillance. So they actually give money to research to improve search and retrieval and to do forensics and intelligence gathering on that data. So basically, if you look at these 3 points, you have the individuals, you have sort of the industry, and you have the government sector, and they're all working towards putting more information of themselves online and making this easier to actually retrieve and to infer from it. So there's no counterbalance. But let's focus. I mean, this topic is so big, I could easily fill an entire lecture. So let's then focus basically on what I'm working on, and also because I think, the reason I'm working on this, well, A, it's my background, but B, also my hypothesis is that multimedia data, that means images, audio, and video, as they contain so much information compared to, for example, a couple words of text. Everybody knows that saying an image is worth more than 1,000 words, and that's pretty much true for this issue as well, that this is often an even bigger issue than just text data. But in general, these problems are valid for other data as well. So let's examine the case of multimedia. So multimedia in the internet is growing. As I just said, people post and post and post and post. And so basically YouTube alone, only YouTube, and there's many more video sites out there. YouTube claims that 65,000 videos are uploaded per day. Per day. That means while I'm talking, videos are being uploaded, videos are being uploaded, videos are being uploaded. It's not hard to interpolate that down to 1 second. And then Flickr claims 1 million images uploads per day. Again, per day. And that's just only Flickr. There's many other sites. And then, for example, Twitter. Twitter is mostly these, 100 characters or so of text message. But then also, we figured out by our own study that, it can be about 100 to 120 million messages per day. There's all kinds of websites that actually track that. And sort of if Michael Jackson dies, it goes up. And if nothing happens, it stays down. But then many of these messages actually contain images. And these are hosted by other sites, for example, TwitPic, Y4, Plixi. And if you look at this, it's about every 100th message has an image. That means from 120 messages per day, you have 1 million images as well. So lots of data every day we talk per day, right? And that's only the major sites. And you also should look that other countries have localized services. China just has its own YouTube, for example, and so on. You have to add all of these in order to get the global picture. So it's a lot of data that's uploaded per day. That creates a big computer science problem, right? So the computer science problem here is more multimedia data means there's a higher demand for retrieval and organizational tools. As I said before, people want to find this stuff they're uploading. And that means we have to create techniques that allow image, video, audio retrieval. Now, the problem with that is that this is really hard. It's not a solved problem. We've worked on this for decades. We have improvements, and we should continue working on it. However, it's not that you can just do a face recognition and find all your pictures of yourself, even using Google. Even Google can't do it at this point. So it's a hard problem. That means, what do we do as industry? Because we have this pressing problem that people still upload every day, every day, every day. Well, they create what's called a workaround. If you don't have a solution, you try to put something together to work around the problem. So let's talk about some of those workarounds. One workaround is manual tagging. I think everybody will know this. So basically, in Facebook, you can say, now they're doing it automatically, they're saying this is a face, and the face detection actually works pretty okay. They say this is probably a face, do you agree? And then it's yes, it's a face, and then you basically click on the person who that face belongs to, which then later on enables you to search for all the images that contain this person. However, this is cumbersome, of course. How many images do you tag? Are you really diligently tagging all your images? Maybe, but in reality, with 1 million, just on Flickr, not everybody will tag them. So the point is, what we need to do is we need to come up with some automatic methods to do some tagging, right? So one method that has become really popular is called geotagging. Geotagging is, you know the GPS satellites are up there. That means you can actually find out by using the GPS signal what are the coordinates of the position on the Earth where you're currently standing. So if you take a photo, the cameras pick up that signal and put the coordinates in longitude and latitude into the image. The trick here is it's in the image, except it's in what's called metadata of the image. That means it's encoded, but invisibly. You can only extract this programmatically. And there are lots of programs. They're usually called EXIF viewers, because EXIF is actually the name for that part of metadata. So these EXIF viewers, you do a right-click, for example, on a browser in Firefox. If you install the add-on for an EXIF viewer, and you see something like this. You do right-click, and you see the latitude and longitude of the position. You also see, for example, the name of the camera manufacturer and so on. And originally, this EXIF data was meant to help image editing. because it would put in the lengths, the type of lengths, the lighting conditions, these kind of things. And then it would help an image editing program to do the right choices. But now they put this, basically, the longitude, latitude in, and basically every modern photo camera, every modern video camera, and most of all the modern smartphones do this. You can also do it manually. Why do they do it? Well, because it's awesome. Look, now I can take all the photos, put them on a map, and then say, okay, Sydney Opera House, right there, let me see how it looks like. And especially, social collaboration using these tools is sort of awesome. It allows for all kinds of neat things. And especially it also allows personalized services, right? So you can go ahead and say, oh, you visited the Sydney Opera House, you visited the New York Opera House, you're probably into operas, right? So I can give you a targeted ad. Okay. And how do they do that? Well, there's one thing is sort of the interface you see if you're using a web browser and you're clicking on it. But there's another thing, of course, that is called API usually, or sometimes also SDK. It's basically a programmatic interface. That means instead of using the web browser, you can use a program that you wrote yourself to access the data that's available. And so, for example, YouTube provides what's called the Google Data API that allows you to search not using the web browser, but your own program that you create. And these APIs are usually even way more powerful than what you can see in the interface. So for example, if you go to YouTube right away, you'll see that on YouTube, you can only search using keywords, and there's maybe some advanced search for categories and so on. But using the programmatic interface, using little Python, we'll see that later, you can actually go and say, give me all the videos within a 1 kilometer radius of that particular point on the Earth. So I can say, give me all the videos from Berkeley, or give me all the videos from San Francisco, or from the US, and so on. That does not work in the interface, in the user interface on the browser. It only works if you write your own program. And so using that, we estimated that about 3 million, about 3% of YouTube videos currently have geotags, and about 4.5% of the Flickr images have geotags. And you might say, well, that's not a problem. It means 97% don't. But that's the interesting thing about the internet. 3% already means 3 million videos, and 4.5% of Flickr means already 180 million images. That's a lot of data. Okay, and I'm not the only one pointing out that there might be some issues with that. There was related work. I don't know if you guys know that's called Foursquare. It's a little mobile app where you can log in live and say, I'm here. And then it tells your friends where you are. And actually, it also can tell publicly everybody who runs this Foursquare app where you are. And it was initially meant for dating. So the neat idea is you go into a bar and you say, I'm in this bar and I'm single and don't you want to meet me? It might be a little lower entry barrier than just actually talking to somebody face to face, at least for some people. The point being that people actually used this extensively, and then this site, pleaserobme.com, was actually saying, well, if you do so, you also tell all the people who potentially break into your house that you're not at home. And also you're revealing like your pattern where you go regularly and so on. So that can be good. People can track you. And so they pointed that out. Well, we'll see how bad it is later on. Political question. Here's the technical question. Is this really about geotags? And in fact, I will answer the question, no, it's not. So here's the funny thing, that's how I got to the problem at all, is we have a little project, you can look that up on the web too, it's called the Berkeley Multimodal Location Estimation Project. And so what this project is doing is we infer location based on context and context of photos and videos. Basically what this is we use the 3% or 180 million photos or 3 million videos as training data, so that retrieval techniques can basically match the data that don't have geotags to the data that have geotags in order to find out for the data that don't have geotags where it's from. And the scary part about this is we really did this because we said, faster search, inference, and intelligence gathering even without GPS. That's awesome, right? Because all of the positive sides of geotagging. We actually think we do quite a good job, because basically what we can do is about 15%. You see the bar on the green bar on the very left shows you sort of the best result, which is 15% of the videos that you try to tag actually get within 10-meter accuracy. That means you have 3% that are actually geotagged, and we get another 15% location to that. It makes 18% are now pretty accurately geotagged. And if you actually look on the very right, so the green, the green bar, or one of these bars on the right, you'll see that about 70 to 80% of the videos we get into a 100-kilometer radius, which means we can still tell about which city those videos are. And you know, it's awesome. I mean, this is needed for a lot of stuff. For example, Hollywood really likes to find scenes again so that they don't have to redo them. There's all kinds of really good applications for this. However, what we said is, well, what happens if we repeat the YouTube cyber-casing experiment using this technology rather than geotag videos? And this is what we did. So now, the old experiment is on the left, the other experiment is on the right. So basically, the old experiment was, we got an initial set of videos, we got 1,000 back. So now we only get 170. That's because what we had to do is, we basically had, based on keywords, we had to, in advance, download videos so that we get a subset of YouTube, because we can't query YouTube using our engine, right? So you just get a subset, and then we work inside that subset. And so we find about 107 videos that we start with, that are sort of in the initial radius of, you know, my shack where I can drive, you know, that's basically the initial radius, right? So then the user is about 2,000 only, you know, 50K again, because it's a smaller set. And then, and that's so funny, is the potential hits. That means the hits where the same user uploaded a video on vacation with like very close time frame, and also has a video of his home, sort of was 106 when I did the YouTube query, but it's now 112, even though I start with less. And usually I ask the understanding question here, why is that? The reason for that is that when we do the potential hits using geotags, we are limited to 3% of the videos because we need the geotags. Here, we're not limited to the geotags. We have our engine, we can use all the videos. And now I can go to these 112 again and see I stopped at 12 again to basically just say, I achieved my goal. Unfortunately, it's already too late. Geotags already help us to train machine learning algorithms so that if you don't put your geotag in there, somebody else might have, and we can match back to that somebody else. Ouch. The problem is, you know, even though I'm in favor of those 51%, maybe we should put some constraints in there. The problem is this really about geolocation? Are we really talking geolocation is evil? And the problem here is, no. Of course, we found out it's not really about geotags. It's not really about geolocation. It's about the search and retrieval capabilities that we really need in order to find our data. So once we are able to find data, we have this problem. And let me show you how. Just one other example. And that is totally different example, and I have to quickly go through it, which is many people have videos on YouTube and they're not anonymous. They're basically saying maybe it's some lecture, you know, I will be on YouTube, I guess, right then? Yes, and so there's some lecture online and they'll say my name and I'm really proud of that and so on. But then maybe the same person is also dating or something, right? So on dating sites nowadays, you can put videos online, right? But the idea is the dating site promises you're really private. We don't tell anybody what your name is, where you live, and so on, until you feel comfortable and you give it out yourself. What we say, they probably cannot keep that promise, because once you have videos on both sides, you might be able to mesh them. And that's actually what we wanted to try out. And actually, we did make it a little scarier by not just using all our expert knowledge and try to match those videos. We said, no. Let's use some program we can download on the internet that is actually new GPL. It's called Alize, and it's made for speaker verification, even though later on we used it completely differently. So the way we used it is we took one person, basically all the YouTube videos, and trained this as a speaker. And then we took a lot of videos and tried to find if all these videos, basically one of them can match to back to that YouTube speaker that we know we identified. Basically, can we de-anonymize the videos of the dating site using the audio track? And the funny thing about this is these videos often don't even contain so much speech, so it was not really about speakers. And of course you'll say, oh, but all this stuff, this is currently research. Right, it's not working perfectly, but that's not the point. So if you do this research, you'll find you get a curve like this, which at this point I don't want to explain other than it basically, if you look at this, you have two things on that curve. One is the probability that if the system says this is a match, then it's actually not a match. It's a false alarm. It's sort of like every Wednesday at 12, the alarm goes off, right? But it's not an alarm. And then the misprobability, which is basically, I don't find those matches, even though they're there. And you can plot them, you get a curve like this. And most importantly was that number, which is, if it's 50%, it's random. We are better than random. Okay, better than random, the question is, what does that give you? Because that's really pure academic experiment. But here's the thing, and that's the most important thing. We can miss a lot of videos because there are so many out there, right? And then all we need to do is get the false alarm rate down, because what we need is one hit to link to accounts. We only need one hit. So basically, if the system misses 90% of the internet, but all the hits we're getting are really reliable and we only need one hit, well, then actually we can use the system. And so basically our result is, in the end, on the average, if you have 20 minutes of video on YouTube side, which is easy, just my lecture is more than 20 minutes, and 20 minutes of video on the dating side, or the semi-public side, then there's a 99.2% chance for one true positive hit, which is all I need. That is actually very scary. It doesn't have to do anything with geolocation, doesn't have to do anything with the stuff we were talking about before. It has to do with the fact that multimedia data has so much information, and we think the reason why this worked really well is because people use the same camera whenever they record themselves. So just a couple of solutions that don't work. So now you're probably pretty scared, and I sort of part of the thing is to scare you, but part of the thing is also to really have you think objectively about this. The problems that we face as computer scientists. But first of all, a couple of solutions that don't work. First of all, you say, I burn my faces. Well, it don't work. You just saw audio tracks you can match, right? Then I say, oh, I only share with my friends, right? So I don't share any videos or photos with my friends. But then who are they sharing with, right? That's the other problem. And then I don't do social networking, but the problem is, and I think that's one of the biggest problems is, I can do it for you. So, I mean, if you don't have a Facebook profile, nothing holds you back from creating one for you and hurting you in some way. Right? So that's the other problem. A handout, and it's pretty clear. And it's just my personal advice. There could be way more advice. And second, if you need more examples and more discussion, I encourage you to go on this blog. I'm collecting all kinds of examples like the ones that I showed on this blog. And that will hopefully educate you about the possibilities, and maybe also about the possibilities of doing good things with it versus, the negative side of it. Thank you very much.
Thank you very much. That's awesome.